Now, this one I think is a little bit more confusing. It's how we handle resistors. And again, it's hugely important that we keep our rules consistent. So when you handle resistors, how you handle the potential difference of the resistor depends on the direction you analyze and the direction of the current. For example, let's look at our same circuit. So I'm going to just actually copy and paste this circuit to the next page. And let's get rid of these. Okay. And since we're going to reuse this, I'm going to go ahead and copy this to another page, just in case we're going to need it again. And that way we have it for later. All right, so let's look at how to measure the potential difference in going across a resistor. Now, to do that, let's look at the direction of current. So let's say we said earlier that current in the branch with the battery is going clockwise. And then we set the current through resistor 1, we called I1, and the current through resistor 2, we called I2. Now remember, current goes from high potential to lower potential. So if current in resistor 1 goes from point B to point A, that must mean point B is at the higher potential and point A is at the lower potential. So if we wanted to evaluate the voltage, the potential difference between points B and A, we need to decide on the direction we're going to evaluate the voltage and how it relates to the current. So let's say we choose to evaluate the voltage from B to A. So I will call this path 2, from B to A. So for path 2, the potential difference from B to A, we are going from high potential to low potential. But instead of looking at it like that, because you're not always going to know which point is the high potential and which point is the low potential. So what I find useful is comparing the direction of analysis with the direction of the current. We are analyzing from B to A, and the current is from B to A. When your path of analysis is in the same direction as the current, then the voltage goes lower. It goes from higher potential to lower potential. So the voltage from B to A, since it goes lower, is equal to minus the current in that resistor times the resistance of that resistor. Key point, when your analysis is in the same direction as the current, it is a minus the product of the current and the resistance. Well, let's say you decide to go from A to B. A to B is just opposite the direction of B to A. I'll call this path 2 prime. So 2 prime, we are going from A to B. And in going from A to B, well, I'll still do my B to A like this, but we are going from A to B. Yet the current is going from B to A. So notice the path of our analysis is opposite to the direction of our current. Whenever the path of analysis is opposite to the direction of current, your potential across the resistor increases. This would be the potential from A to B is equal to positive the current through that resistor. Oh, and I should have called this I sub 1 because it's the current through resistor 1. So put that subscript 1 on these currents. So the potential from A to B is positive I sub 1 times the resistance of resistor 1. Now, why is that again? Well, again, we said point B is at the higher potential. Point A is at lower potential. So if our analysis goes from A to B, that means we're going from lower potential to higher potential. That means the potential difference of our resistor increases. So here's the moral of the story on this one. The thing to remember is this. When you analyze the potential difference across a resistor in the direction of the current, the potential decreases. So it's a minus current and resistance. On the other hand, if you analyze across your resistor in a direction opposite the direction of the current, the potential increases, going from low to high, and that's equal to the product, the positive product of the current and the resistance.